In this lecture, I am going to tell you a secret. And that secret is that lambda functions in C++ are modeled behind the scenes by using functors that we just learned about in this chapter here. Let me show you a simple example. Here we have a simple lambda function which has an empty capture list as we have here. We have a bunch of parameters. We have two in this case. And we have a body for this lambda function, and it is basically going to return the sum of the two parameters, x and y. And we are giving it the parameters that it can work with. So we are setting up the lambda function and calling it directly with these parameters. And the result is going to be stored back in our variable here. So if we print this out, we're going to see whatever we passed here summed up, and we should get a 10 in this case printed out. So this is our lambda function. We already know about lambda functions. We have learned about them earlier in the course. But now we want to understand how they are modeled and how they work behind the scenes. And when the compiler sees code like this, it is going to generate a functor which is really going to make this lambda function work behind the scenes. And the functor that is going to be generated is going to look something like this. And it is going to have the same logic we have in the lambda function built in. So remember, our lambda function was just summing up two parameters and returning the result. The functor that is generated, it is going to do the same thing. It is going to take two parameters as you see here, and this is our function call operator that makes this class here a functor. And our member function here is going to be const because it's not going to modify the class in any way. And it is going to return the summation of these two things. So the compiler is going to create this class behind the scenes, and then it is going to create an object of it, and then call this operator to give us the logic that we have in our lambda function here. And we're going to have a chance to prove this in CPP Insights, and I think we can actually go there right now. So let's do that. Here we are at CPP Insights, and we're going to take out this lambda function that I had here. We're going to set up one from scratch to really do the same things we were doing in our slides. So we're going to say auto value, which is going to be the value we get from our lambda function. We're going to set up a lambda function which is empty, and it is going to sum up two double parameters. We're going to put in a double A and a double B. I think we can do something like this. Then we're going to put a body in. And in the body, we are going to return x plus y, or we should return a plus b in this case. This is going to do. So what we intend to do in this lambda function is sum up the parameters that we get in our parameter list. And then we want to call this lambda function here. So we can pass in 10 and 20, for example. This is going to do. And let's try and run this through CPP Insights and see what we get. Let's clean up a little bit, and we're going to pass this through our tool. And we have our response, and you see that in the main function, we have generated a class. You see it is called lambda whatever. So this name is really random. That's what the compiler is going to generate behind the scenes. But notice that we have a function called operator, which is going to return double. And it is going to take two double parameters. It is const. It is exactly what we really want to do within this lambda function here. This lambda function is going to sum up two doubles and return a double. That's what is deduced here. And that's what we have in our function called operator here. We don't really want to worry too much about the other boilerplate code that the compiler generates. The main message is that if you set up a lambda function in your code, the compiler is going to set up a functor that it's going to use to support the logic you want in your lambda function. And after the functor is set up, the compiler is going to create an object of it. You see the object created here. And then we're going to call our function call operator and get the result to be stored wherever our lambda function is storing the value. So the value is going to be put back in this value variable, and we can use that however we want. The main message is that lambda functions are modeled behind the scenes by using functors, and we're going to have much more to learn about this. For example, to see how the capture mechanism works, we're going to have a chance to learn about those things. But for now, note that lambda functions use functors behind the scenes. That's the message I want to convey here. Okay, so the lambda function here is going to be modeled behind the scenes by using a functor like this. It is also possible to specify a return type to our lambda function by using a trailing return type here. And if we set up something like this, the compiler is going to generate a functor which is going to explicitly return int from our function call operator. So this is what we're going to have. Again, the names for these classes are going to be randomized by the compiler. You shouldn't really rely on these names, and I don't even think they are available to you in your C++ code. So this is the message I want to convey here. Any lambda function is going to be supported by a functor behind the scenes, and you can go in CPP Insights and try to prove that yourself. Okay, now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is functors and lambda functions. We're going to grab our template files and copy them and put them in place. And we can open this up in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file. We're going to clean it up a little bit. And we will set up our lambda function. It is everything you know so far. We're going to set up a lambda function with an empty capture list. We're going to specify two parameters, and this lambda function is going to return an integer, and we're going to give it 7 and 3 to sum up, and the result is going to be stored back in our result variable here, and we can print this out. We can pass this through our compiler, so let's use GCC for that. The bold is going to be good. We can bring up a terminal window, and if we run this, we should get our sum printed out, which is going to be 10. This is really nothing new. But if we come back to CPP Insights, we're going to see that the compiler is going to generate a functor behind the scenes. It is going to create an object of this functor and call our function call operator net to do our dirty job. And we're going to get a result in our value here that we can print out. So this is the logic I want to convey. Any lambda function, again, is going to be powered by a functor behind the scenes. Another thing we can do is try to grab the type of the lambda function and see if we can deduce that and store that in a variable. For example, if we do autofunc here, we're going to see that func was deduced as a function which takes two integers and returns an integers n. So this is the type for the function call operator in our functor. We're going to see that we have our input and we have our output, but we don't have direct access to the name of the class that the functor is using behind the scenes. That's to be used by the compiler. We shouldn't really have access to that because the main driving effort for setting up lambda functions was that you didn't want to set up objects for functors every time you wanted to call them. So the compiler is going to take over the job to generate the functor behind the scenes. It is going to create an object of that functor, and it is going to call the function call operator for you, and you're going to get the result right away. And this is going to be really cool. And this is really not adding any more value on what you could do before you learned about this lecture, but it is going to help you understand what is happening behind the scenes when you work with lambda functions in your C++ programs. This is really all I had to share in this lecture. Again, the main idea is that lambda functions are powered by functors behind the scenes. We are going to stop here in this lecture. In the next one, we're going to see that we can actually use lambda functions as callbacks because lambda functions are functors after all. So go ahead and finish up here and meet me there.